Hi, welcome to Learning Monkey. I am Raghu here. In this class, we'll discuss some basic theorem. Based on this basic theorem, which we are going to discuss in this class, we are going to use this theorem in our next class, where we are going to discuss about the finding of GCD using Euclidean algorithm. If you want to understand our next class, this theorem is going to help you a lot in understanding the next class. And in our last class, we clearly discussed about division theorem. Please watch that class and come back here. We are going to use that theorem here in this class. The link for the playlist is provided in the description below. Coming to today's class, so a little bit confusing, but it is very easy to understand. If you correctly catch the point, it's easy. Otherwise, you'll get confused. So if A is equal to BQ plus R, what is this equation? This equation, in our last class we clearly discussed that this is the division theorem basics. A divides B, then this can be written as A is equal to BQ plus R. This is quotient and this is remainder. A, B, Q, R are integers. If you take this equation, then we need to show that GCD of A comma B, GCD means greatest common divisor of A comma B, equal to GCD of B comma R. This is what we are going to show in this class. If A is equal to BQ plus R, this happens, then we can show that GCD of A comma B equal to GCD of B comma R. So now coming into the proof, A is equal to BQ plus R. This is what we considered. If this happens, we are assuming that D1 equal to GCD of A comma B. D2 is equal to GCD of B comma R. If you show that D1 equal to D2, then it is accepted. That is what we are going to do here. We need to show D1 equal to D2. We are assuming that first. We are assuming D1 is equal to GCD of A comma B. D2 is equal to GCD of B comma R. Below we need to show that D1 equal to D2. Now let's try to understand how we need to show that D1 equal to D2. We are assuming that D1 is equal to GCD of A comma B. What's the meaning of GCD? Greatest common divisor. Means D1 divides A. D1 divides B. Yes, that is what GCD means. It is going to divide both A and B. In the common divisor, GCD means greatest common divisor. So D1 is equal to, we are assuming that D1 is equal to GCD of A comma B. Then definitely we can say that D1 divides A, D1 divides B. Yes, we can say that. Now from this, if D1 divides A and D1 divides B, then definitely we can say that D1 also divides R. Why we can say that D1 also divides R? Because the given equation is like this. Because A is equal to BQ plus R. That is what the equation says. From that equation we can write that R is equal to A minus BQ. So from this, see here, A minus BQ. We are assuming that D1 is equal to 5, A is equal to 45, B is equal to 10. For better understanding, we are taking numbers. Q is equal to 4. So, if D1 divides A, 5 9s 45. D1 divides B. What is B? 10. 5 2s 10. Then definitely D1 divides R. R means A minus BQ. Yes, D1 divides A, D1 divides B, B multiplied by some integer, then definitely D1 is going to divide. See, B is 10, Q is equal to 4, 10 4s 40, D1 is going to divide BQ. Because D1 divides B, D1 divides A, then definitely D1 divides BQ. D1 divides BQ, D1 divides A, then definitely A minus BQ is divisible by B, D1. From the basics of 10th class. These are the 10th class basics of divisions. D1 divides A, D1 divides BQ. Then definitely A minus BQ is divisible by D1. You take any form of numbers, you try it. Definitely it is going to divide. So from this, A minus BQ means R. So D1 is going to divide R. So that's why if D1 is equal to GCD of A comma B, then D1 divides A, D1 divides B. Then obviously D1 is going to divide R. Hence, any common divisor of A comma B is also common divisor to B comma R, because the equation satisfies A is equal to BQ plus R. You take any common divisor of A comma B, it is going to divide, it is also common divisor to B comma R. The above is the proof which we have shown. So from that we have taken that D2 is equal to GCD of B comma R. GCD means greatest common divisor of B comma R. Then definitely from this we can say that D1 means GCD of A comma B. Then definitely D1 less than or equal to D2. From this we can say that. Because D2 is GCD of B comma R. Assume that if you take any common divisor, D1 is common divisor of A comma B, then definitely this D1 is less than or equal to, because it is D2 is GCD of greatest common divisor of B comma R we have taken. Similarly, the exact opposite also we have to show. Means we have taken D2 is equal to GCD of B comma R. What's the meaning of that? D2 divides B, D2 divides R. If D2 then D2 divides A also. If this 2 happens, then D2 divides A also. Why? Because A is equal to BQ plus R. The same logic, D2 divides B, then definitely D2 divides BQ, because it is a multiple of some integer. D2 divides BQ, D2 divides R. Addition of these 2 going to divide by D2, which is equal to A. So that's why if D2 is equal to GCD of B comma R, then definitely D2 divides B, D2 divides R. Then definitely D2 divides A. Why? Because A equal to BQ plus R. This equation is satisfied. That's why if this happens, then only we need to show GCD of A comma B equal to GCD of B comma R. If this is not happen, it is not going to be true. So from these statements we can say that hence common divisor of B comma R is common divisor of A comma B. The opposite we have shown in the above. We have shown that common divisor of A comma B is common divisor of B comma R. Here we have shown the reverse. So from this we can say that assume that D1 is equal to GCD of A comma B. Then definitely we can say that we have D2 less than or equal to D1. D2 is the common divisor of B comma R. So D2 is definitely less than or equal to D1. So from this statement, here we have proved that D2 less than or equal to D1. Here we have shown that D1 less than or equal to D2. Is this happens? This happens only one time. When this happens, D1 equal to D2. So we say that D2 is equal to D1. So in the initial we assumed that D1 is GCD of A comma B, D2 is GCD of B comma R. Both are same. So if A is equal to BQ plus R, then definitely we can say that GCD of A comma B is equal to GCD of B comma R. This is the statement we are going to use in our next class to show the theorem. Hope you understand this GCD equal to B comma R is equal to A comma B. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.